Hello everyone. Today I want to talk about asynchronous programming. First of all, what is asynchronous programming? Without going to the codes, let's examine the daily life. Some of the actions we can take one by one. We have to take them one by one. For example, we buy a new house and we move out from the old house and we move in to the new house. We can't. We have to follow the sequence of this order. We can't move out before buy a new place, otherwise we don't have any place to live. And we can't move in before we move out. But some of the actions we don't have to take them in particular order. For example, um, after we bought our new house, we need to ask someone to clean it up, to paint the wall, or maybe we want to make a new kitchen. So we want to clean up the house, but at the same time, we can start packing. We don't have to wait till the cleaning up is finished before we start packing. We can do them at the same time. So this, in computer language, we can call it asynchronous programming, whereas this is called synchronous programming. All right, let's take a look at the C# codes, how asynchronous programming is implemented in C#. So before we examine how synchronous programming works in C#, let's take a look at the codes that runs normally, synchronously. So we have three calculation functions. It doesn't do any calculation, just returns number. Um, and the first one, we're using sleep, thread.sleep, to simulate the situation where this calculation takes longer time than the others. And we have this. This is a calculation just calls the other ones, and it's called in the main function. That is the entry point of the console application. So if we run this application, the lines of code here will run one by one in this order. The order will not be messed up. It has to be the first one runs, and then the second one, and then the third one. So as you can see, it says calculating result 1, calculating result 2, calculating result 3. So if we look at the calculation, the three calculation functions carefully, we can see that they don't actually depend on each other, right? They don't depend on each other at all. So there's no reason why we cannot let them run in parallel. And how do we do that? In C#, we have this asynchronous programming functionality introduced a long time ago. So, and that's called something called task. So we can use task to run these functions asynchronously. And the way to do it is to do task.run. And we can use lambda expression. Right. So we can run the first one, and then we run the second one, and we run the third one. Second one, and then third one. And let's give it a try. All right, so this time the result looks different. calculating result 2, calculating result 3, and calculating result 1. Why this time the order is different? Because the first time, if you remember, it says calculating result 1, and then result 2, and then result 3. This time, why result 1 becomes the last one? And when we look at the code, the result 1 has a sleep statement to simulate that it's a long-running process, whereas result 2 and 3 returns right away. So that's why we see this happens. Secondly, this is output first. Firstly, this is output secondly, and finally, this one was output. So this tells us that at least the first one was running while the second one and third one was running. So the reason why the third one still comes secondly after the second one was because calculate 2 was started, and then right away calculating 3 started. So because calculation 2 returns immediately, so this one still finishes before this one. But because calculate 1 takes 3 seconds to finish, so that's why we're seeing that the output goes result 2 first, result 3 secondly, and then result 1. Right, so let's examine a different scenario. That let's say calculation 3 depends on calculation 1 and 2. Okay, so let's put some parameter here. Result 1, result 2, and we're returning result 1 plus result 2. Okay, and so in this case, we cannot call it this way because otherwise, first of all, we cannot get the parameters. We cannot get the return value from calculate 1 and calculate 2. Secondly, result 3 will run before result 1 finishes. So what should we do in this case? Okay, so in that case, we need to do something like this. Return the task for the first two, and here we need to return the value. Well, yeah, return the value, and here we need to say we want to wait for both task 1 and task 2 to finish. So there is something called WaitAll. So you can do WaitAll or WaitAny, and then we can say task 1, task 2. We'll wait for all of them to finish, and then we can get a waiter. A waiter 1 equals task 1 dot get a waiter, and a waiter 2 equals task 2 get a waiter. And from a waiter we can get the result. So we can get result 1 equals waiter 1 dot get result, and result 2 equals a waiter 2 get result. So in this case, we are able to get the result from 1 or 2, from calculate 1 and calculate 2. And then we can feed it to calculate 3. Calculate 3 with result 1 and result 2. Okay, let's run it. See, this time the sequence is different again because calculate 1 runs first, but it takes longer for it to finish. So that's why calculate 2 prints to the screen first. Calculate 2 prints to the screen first, and then calculate 1. And because calculate 3 waits to both of them to finish, that's why calculate 3 appears on the screen on the third place. All right, so let's see a different scenario where maybe calculate 2 depends on calculate 1. Right, so calculate 2 depends on calculate 1. In that case, we want to change this to result 1, and then we want to do result 1 times 2. We can return this. And so this makes result 2 relies on result 1, but result 3 does not rely on result 1. So what we need to do in this case is that we need to, maybe we can use this. We want to get the awaiter 1, right? We got awaiter 1, and then we can say awaiter dot uncompleted, right? So we were waiting for the task 1 to complete. And then inside here, we can get a result from awaiter 1. We can get, so here, awaiter 1, when awaiter 1 completes, which means when the task first task completes, then we use awaiter 1 to get the result. This is the result from calculate 1, which is the integer. And then we can call calculate 2 and feed the result 1 to calculate 2. And after that, we call calculate 3. We can make calculate 3 has no relationship with calculate 2. This does not depend. It does not depend on calculate 1 or calculate 2. So here we just return 300. Right? In this case, we look at it again. Task 1 runs, but then when it finishes, it calls this. So this is so-called callback function. This is callback function. So lambda expression, it's a delegate, and this is the function. This here is the function, and what it does is that it gets the result from task 1 and then calls calculate 2. And this is asynchronous call, so calculate 3 will run first because it takes a long time. It takes 3 seconds for task 1 to finish. So what we'll see is that it will say calculating result 3, and then it will print calculating result 1 and calculating result 2. So let's see whether it does that or not. So calculating result 3, that comes first, and then 1 and 2. So this is the asynchronous programming functionality in C#. There's a lot of different other things, but this is the basic of the asynchronous programming in C#. And it's using a sort of callback. And if we want to wait for something, we can use task.wait, either wait any or wait all. So there's another thing that we nowadays see a lot of a function that says async at the first, and then inside it says await. So what is about those? What is about the async and the wait keywords? It looks sort of confusing because it looks like it's not a asynchronous programming. It looks like a synchronous, like everything is being called synchronously, and that's actually the point. The point is that to simplify the asynchronous programming, so that it has a feel of synchronous programming, but it's a double-sided sword. It is actually indeed confusing. So this way, when we do it this way, it's actually pretty clear that um, this is a callback function, and this runs first. I mean, these will run first, but then it will go through, and then this will actually go through really quickly, and then we'll run this one, and then when all of that finishes, it calls inside. So this structure is pretty clear, but um, but it's probably nicer if we can make it look like asynchronous programming. So let's see how we let's say in this same case that calculate 2 depends on calculate 1 and calculate 3 does not. In this case, what do we do? Right? So what do we do? How do we use async and then wait to implement the same thing? So for that, we want to create um, a new function. We call it task. I'll calculate 1 and 2, and inside here we are going to call this, copy this over here, right? And we are going to await this. And when we await it, we will actually get the result from here, right? And this result is an integer. And here because we're waiting for calculate 1 to finish, then at this line we will get the result already, right? We'll get it so that we can calculate 2. We'll feed it to it. So in this case, we can calculate 1 and 2. Yeah, this is supposed to be static. So we're calling this function, and because we are not awaiting it, we're not waiting it to finish. So as soon as this executes, this calculate 3 will be executed, right? And then let's run it and let's see how it works. So it does the calculation 3 first, and then does the calculating 1 and calculating 2. And let's see how it works. So this function gets called first. And what happens here is that it runs calculate 1, and actually it will actually return from here and then directly calculates this. And after this calculate 1 finishes, it will come back and execute calculate 2. Right? Hopefully that's clear. So 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 again, calculate is called, and calculate 1 2 function, which is this function, is called. When this function is called, this task gets executed. But because we have a wait keyword here, this async and await makes this calculate 1 underscore to function, a asynchronous function. So we'll actually return right away. Kind of like finishes, but kind of like a pauses right away. And then it will execute the next line, the next line, the next line. As soon as this task finishes, it will continue from here. Remember, it paused. So it will continue from where it paused. So it will continue from here. That's why we saw calculating 3 first, and then calculating 1, and then calculating 2. It didn't show calculating 2, right? It showed calculating 1 before showing calculating 2. So calculating 2 is actually waiting for calculating 1 to finish, but calculating 3 runs first because this is an asynchronous function. What if we add async? What if we add a here, async, and then we here, if we right, and we make this return a task, and we await this one, await to calculate 1 and 2, and then we call it. We can await this one. So yeah, so what if we create another static method and call it test? And from here, we make this one async, and we await calculate, await calculate. Well, we have to await, get a task here, and if we do this, what will happen? Guess what will happen? I'm gonna put a test here, of course. So the task will be called, and then it will await this to finish. And when this is called, we'll await 1 and 2 to finish. Right? So calculate 3 will not be called. Instead, calculate 1 will be called. And when 1 finishes, so it actually pauses here, right? But then when it finishes, it calls calculate 2. And when calculate 1 and 2 finishes, it calls calculate 3. So when we run it, we'll see that calculate 1 prints first, and then 2 and 3. So we'll by the normal sequence. See? 1, 2, and 3. Yeah, I think that's all I want to talk about today about asynchronous programming. And I hope that is helpful. If you like it, please give it a thumb up and subscribe as well. Thank you so much.